In this example, we are going to introduce the notion of finite capacity region. Consider this queuing network with three queues. We run a simulation where we try to look at the number of jobs inside the Q2 and Q3. We let the simulation run for a bit and we will see that this number is just below 20. Now the simulation is completed, even though the statistical estimator reports a possible problem with the convergence, we might assume that these results are correct, and therefore about 18.5 jobs are inside Q2 and Q3 on average. Suppose now that we want to constrain the maximum number of jobs that are at any given time inside the Q2 and Q3 altogether. So what we can do is that we select these two queues and wrap them around with a finite capacity region. So as we click FCR, a finite capacity region is created around Q2 and Q3. Let's click on this FCR. As you can see, there is a field, region capacity, where we can set the maximum number of jobs that can enter this FCR region. For example, we might set this to 10 jobs at most. The row below specifies which policy should be used by JMT to cope with the jobs that cannot be admitted to this FCR because there are already 10 jobs inside. The drop policy means that the jobs will be discarded, so let's select first a policy that does not discard the jobs. In this case, as we rerun the simulation, we will see that the number of jobs inside the two queues is roughly equal to 10 as we sum the number of jobs in Q2 and Q3. What we have done is that the jobs that arrive when these two queues have in total 10 jobs inside are queued in an invisible buffer here at the entrance of the FCR, waiting to enter this region. As soon as one job will leave Q3, the job at the head of this buffer will be let in the FCR and will queue in Q2. A different policy that we might use is the drop policy, in which jobs that arrive while Q2 and Q3 contain in total 10 jobs are simply discarded and are no longer considered in the simulation. So as we start this simulation, we can see that the results are quite significantly different from before. And this is because there is a substantial number of jobs which never make it into the FCR. Among the features of FCR is a set of performance indices that are FCR specific. For example, we can define response time or number of customers relative to the full region as opposed to individual queues. As we run these indexes, we will see that the value that we obtain in the case of dropping is fairly close to the sum of the individual values at the queues. And this is because no job is allowed to queue in the admission buffer at the entrance of the FCR. Let's see how this value changes if we disable the dropping. In this case, there will be a queue invisible at the entrance of the FCR. And we see, in fact, that the index for the finite capacity region indicates that there are about, on average, about 60 to 70 jobs that are waiting to enter the queue or that are already inside the FCR. So 62 includes the number of jobs in Q2, Q3, and the invisible admission buffer. As we look at the response time, this index will therefore include not just the sum of the response times at Q2 and Q3, but also the time spent in the admission queue in order to enter the finite capacity region.